In this lecture we're going to look at bonding and non-bonding electron pairs and look at the effect they have on the shapes of molecules and polyatomic ions. By the end of this lecture you should be able to explain the difference between a bonding electron pair and a non-bonding electron pair. And furthermore, you should be able to predict how non-bonding electron pairs affect the shapes of molecules and polyatomic ions. In order to explain the difference between bonding and non-bonding electron pairs, it is necessary to learn how to draw electron dot diagrams. They're a bit like the method we used to use in National 5 to demonstrate how a covalent bond was formed. For example, here's a hydrogen molecule. So at National 5, if you'd been asked to draw a diagram showing all the outer electrons to show how a covalent bond is formed in a hydrogen molecule, you should have drawn a diagram like this, with one electron from each hydrogen atom in the shared area of overlap, which is represented by this line in our normal representation of a hydrogen molecule. Now, when it comes to doing electron dot diagram, it's really just like this. Now we take the circles away. So for example, that would be an electron dot diagram to show the hydrogen molecule. Various alternative versions are acceptable. You could do one a dot and one across to differentiate between what electron came from what atom, but it's not necessary. Either of those are acceptable. Again, in the National 5 course, if you had to draw a diagram showing all the outer electrons to show how a fluorine molecule is formed, your diagram look a bit like this. Now, fluorine being in group 7 has got 7 outer electrons, one of which it donates in there, and the other 6 aren't in the covalent bond. And the same with the other fluorine atom. So at advanced higher, the way we do that would be like this. And as I said previously, you could use dots and crosses if that makes it more intelligible. I actually think it's slightly more easier to understand if you make the electrons from one atom dots and the electrons from the other atom crosses, but you don't have to. Now, in a molecule of fluorine, we see both bonding and non-bonding electron pairs. The bonding electron pairs are those pairs which are involved in the covalent bond, which are this pair here. They are forming the covalent bond between the two fluorine atoms. That is a bonding electron pair. But all the other ones, let's see. So that pair there, 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 and that pair there. They're not involved in the bonding, so they're non-bonding electron pairs. So that's the difference between bonding and non-bonding electron pairs. The bonding electron pairs are the two electrons involved in the formation of the covalent bond. If the electron pair are not involved in the formation of a covalent bond, they are a non-bonding electron pair. Okay, So let's now look at an electron dot diagram for the molecule CH4. Now, when we've just been asked to do an electron dot diagram, we don't need to worry about getting the true shape of the molecule right. We're just showing the electron pairs. So, carbon being in group 4 has got 4 outer electrons. Put one there, one there, one there, one there. And each hydrogen donates 1 electron. So, this molecule has got 4 electron pairs, and they're all bonding electron pairs. So if we now try and do an electron dot diagram for that NH3 molecule, again, I'm not worried about the shape here. Nitrogen has got 5 electrons, 5 outer electrons. One goes into that covalent bond, one goes into that covalent bond, and one goes into that covalent bond, leaving 2 electrons left over. And then the hydrogen donates its electron there, there, and there. So we've got 3 bonding pairs of electrons, 1, 2, and 3, and 1 non-bonding pair of electrons. Finally, if we do the same for a water molecule, H2O, water has got 6 outer electrons. 1 goes into that covalent bond, 1 goes into that covalent bond, leaving 4. Put 1 pair up there, 1 pair down there. And the hydrogen donates its electron there and there. So in this case, we've got 1, 2 bonding pair of electrons and 1, 2 non-bonding pair of electrons. Okay, so what? Why are we interested in whether electron pairs are bonding or are non-bonding? Well, our interest lies in the fact that the shape of the molecule is not the same as the arrangement of electron pairs if non-bonding electrons are involved. If all the bonding pairs around the central atom are bonding, all the electron pairs around the central atom are bonding, then the molecule will be the same shape as the arrangement of electron pairs. But that is not the case if there's non-bonding electron pairs involved. So, in methane CH4, we've got 4 electron pairs as worked out previously. So 4 electron pairs gives us an electron arrangement of tetrahedral, and that's what we get with the classic 109.5 degree angle between that carbon-hydrogen electron pair and that carbon-hydrogen electron pair. If we look at ammonia, however, NH3, the nitrogen's got 5 electrons and then 1 from each hydrogen, gives us 8 in total, 4 electron pairs. The electron arrangement is tetrahedral. However, only 3 of them are bonding electron pairs. We've got a non-bonding electron pair here. So when we're asked to describe the shape of the molecule as opposed to the shape of the electron pairs, okay, so please be careful about what one of those 2 things is being asked. We sort of ignore the non-bonding electron pair, which leads us the shape of the molecule being this, the classic pyramidal shape that we learnt at National 5. So there's the shape of our molecule as opposed to the shape of the electron pairs. And if we look at water with its 2 non-bonding electron pairs, so the shape of the molecule, which is this shape here, it's got various names. It says bent here, We also use planar or angular planar to describe its shape. So in these cases where we've got non-bonding electron pairs, the shape of the molecule is not the same as the shape of the electron arrangement. So make sure you know what one you've been asked to calculate. Finally, I just want to draw your attention to the bond angles here between HN-NH, or here the HO-OH. You'll see that they're slightly less than 109.5. 106.7 for pyramidal, 104.5 for the water. Now you don't need to remember these exact angles, but you should be aware that they're smaller than the classic tetrahedral shape. And that's because the non-bonding electron pair repels the other electron pairs more strongly than a bonding electron pair. So this non-bonding electron pair really slightly shoves these electron pairs closer together, making that bond angle slightly less than the classic 109.5. And this is exaggerated even more in the case of water, where there's two non-bonding electron pairs pushing these further closer, so the bond angle is only 104.5. So it's essential that you remember that non-bonding electron pairs are more repulsive than bonding electron pairs, and so we'll close up that angle from the classic tetrahedral to a slightly lesser angle. So you should now be able to explain the difference between a bonding electron pair and a non-bonding electron pair, and you should be able to predict how non-bonding electron pairs affect the shapes of molecules and polyatomic ions.